Hello, this is Mr. Stansbury. I'm going to take you through the 14D notes on sample space. At the end of this, you should be able to say I can find all the possible outcomes of an experiment using various methods. Okay, so first thing, let's talk about sample space. It is simply the set of all possible outcomes of an experiment. Okay, so for example, example 2 from page 462 has us list the sample space of possible outcomes for tossing a coin and rolling a six-sided die. So really all you got to do is just list all the possible outcomes just like it says, and we list it in the brackets, which means the set of, in this case, the sample space. So tossing a coin, we're going to get heads or tails. And there we have listed the sample space for that. Rolling a six-sided die. 1, 2, 3. That's a 3. 4, 5, or 6. And there's a sample space for that. Okay? Rocket science? I think not. Let's see. List the possible outcomes. Example 3, page 462. List the possible outcomes when two coins are tossed using a two-dimensional grid. Okay, so we can do, say, let's go with coin 1. We can either get heads or tails. And then coin 2, we can either get heads or tails, right? So we go through and list our sample space there. We can just put, say, dots for head, head, tails, heads, heads, tails, and tails, tails. Okay, so there's our grid. And so then to list our sample space, list the possible outcomes. So really our sample space is just listing all these. So let's go with, say, heads, 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 and then maybe heads, tails, tails, heads, and tails, tails. And that is our sample space. All right. One last example to look at is example 5 from page 463, which has been modified just a little bit. John and Peter are having a sumo ski jumping contest. And there is a fine example of sumo ski jumping. And the first to win the longest jump twice wins the competition. Illustrate the sample space using a tree diagram. Okay, so let's say here, let's do the first jump. Okay, and we can get two possible outcomes from the first jump. All right, so we can get two winners. That was bad. Let's make this nice and wide because we're going to have to make a tree diagram go farther down. So first jump can either be John can win or Peter can win. All right, either way, on the second jump, we'll need to keep going. So again, on the second jump, if John wins the first one, either, let's see, John can win the second one or Peter can win the second one. And if Peter wins the first one, either John can win or Peter can win. Okay, so it says in here that the first person to win twice wins. So if we get John, John, then that one, then John wins. If we get Peter and then Peter wins. If either of these middle two happen, then you have to have a third jump. How exciting. All right. So if it goes John, then Peter, then the last one we can go Peter, John, and then this one here is Peter, and then John. I guess it could go John and Peter. Let's make it consistent, shouldn't we? Should say, because I always had John first. John, Peter, John, Peter. Okay, just to be consistent. Excuse me. So this way here, if it was this over here, John would win. This way John would win. This way Peter would win. This way John would win. Peter would win, and Peter would win. Okay, so illustrate the sample space using a tree diagram. So then the actual sample space is, it can go John, John, and then we're done. It could go John, Peter, John. Could go John, Peter, Peter. Could go Peter, John, John. Oops. Peter, John, John, Peter, John, or Peter. Peter, John, Peter. Sorry, Peter, John, Peter. This is like a tongue twister. Or Peter, Peter. Okay, and those are the 6 different possible outcomes. The reason why they're having to use a tree diagram here is just to make sure that you hit every single possible outcome. Okay, so I'd like to just leave you with a short little funny video about some animals. All right, why? Because we can. I believe this is a video of the smartest cat and the smartest dog on the face of the planet. Yes. Go animals. All right. If you should be able to say now that I can find all the possible outcomes of an experiment using various methods. All right. If you have any questions, feel free to ask. Thanks.